Hello, good afternoon. Molecular orbital theory. According to molecular orbital theory, all the atomic orbitals of atoms participating in the formation of molecule mix up to form new kinds of orbitals called molecular orbitals. So, molecular orbitals are responsible for the formation of molecules. It means atoms consist of atomic orbitals, but molecules consist of molecular orbitals. Number of molecular orbitals formed equal to number of atomic orbitals mixed. The molecular orbitals assumes that atomic orbitals from the atoms combine to produce new set of orbitals called molecular orbitals. Such molecular orbitals are described by wave functions according to quantum mechanics. Basic principles of molecular orbital theory. When nuclei of two atoms come close each other, their atomic orbitals interact, leading to formation of molecular orbitals. The atomic orbitals of atoms in a molecule completely lose their identity after formation of molecular orbitals. Each molecular orbitals is described by a wave functions known as molecular orbitals, wave functions. The molecular orbital wave function psi is such that psi square represents the probability density of electron charge density. Each molecular orbital wave function psi is associated with a set of quantum numbers which determine the energy and shape of molecular orbital. Electron fills the molecular orbitals in the same way as they fill the atomic orbitals following the above principles, Pauli's exclusion principle, and Hund's rule maximum multiplicity. Each electron in a molecular orbital belongs to all the nuclei present in the molecule. Each electron moving in a molecular orbital has a spin plus half n or minus half. Linear combination of atomic orbitals, principle of molecular orbital theory, the wave functions describing the molecular orbitals are obtained by a method called linear combination of atomic orbitals, LCAO. Molecular orbitals are formed by the linear combination of atomic orbitals. Linear combination of two atomic orbitals wave functions are brought about by addition and subtraction overlap of atomic orbitals. Let psi A and psi B are the wave functions of two atoms A and B, and psi molecular orbital be the wave functions of the molecule AB. A plus B, AB, psi A plus psi B, psi molecular orbital. When two atomic orbitals overlap, the new wave function psi AB and molecular orbital psi molecular orbital is formed and can be obtained by linear combination of atomic orbitals psi A and psi B. Psi AB equal to n T1 psi A plus C2 psi B. N is the normalizing constant which ensures that probability of finding electrons in the whole space C1 and C2 are the constant which gives the minimum energy for psi AB. The probability density for the combination of two atoms is given by square of the wave function psi square AB equal to n C1 psi A plus C2 psi B square. So C1 square psi A square plus 2C1 C2 psi A psi B plus C2 square psi B square. If n equal to 1, 2C1 C1 square C2 square probability finding of electron in A, C2 square psi B square probability finding of electron in B, 2C1 C2 psi A psi B overlap of the atomic orbitals. The larger the 2C1 C2 psi psi B it is, the stronger is the bond between A and B when there is higher electron density in the internuclear region and bond is stronger. There will be two molecular orbitals as the result of the two types of combination as given below. Psi B molecular orbital equal to psi A plus psi B. Psi star that is anti-bonding molecular orbital equal to psi A minus psi B. Psi B means psi bonding molecular orbital equal to psi A plus psi B. Psi star, psi anti-bonding molecular equal to psi A minus psi B. Equation 3 represents formation of bonding molecular orbitals. It is formed by addition overlap of atomic orbitals, that is overlap of atomic orbitals having same sign. Equation 4 represents formation of antibonding molecular orbitals. It is formed by subtraction overlap of atomic orbitals, that is overlap atomic orbitals having opposite sign. Features of bonding molecular orbitals, it poses lower energy than atomic orbitals from which it is formed. It has higher electron density than the two nuclei and stable. It is formed by combining atomic orbitals having same sign, but magnitude of psi is always bigger than psi A minus psi B. Every electron in a bonding psi molecular orbital contributes to attraction between two atoms. Features of anti-bonding molecular orbitals, it possesses higher energy than the atomic orbitals from which it is formed. The probability of finding the electron in between the nuclei is negligible. It is formed by the lobes of combining atomic orbitals have opposite signs. Psi star antibonding is numerically smaller than psi A or psi B. Every electron in an antibonding molecular orbitals contributes to repulsion between two atoms. Atomic orbitals. Uh, Rules for linear combination of atomic orbitals. The combining atomic orbitals should have roughly the same energy. The overlapping orbitals must approach each other closely enough for considerable overlap to form molecular orbitals effectively. For producing bonding and antibonding molecular orbitals, either the symmetry of the two atomic orbitals must remain unchanged when rotated about the internuclear axis, or both the atomic orbitals must change symmetry in the identical manner. Diagrammatic representation of molecular formation of molecular orbitals and atomic orbitals. S overlap, addition overlap. Two S atomic orbitals having the same sign mixes to form sigma bonding molecular orbital C. This is the S orbitals addition, sigma bonding molecular orbitals. Subtraction overlap, two S atomic orbitals having opposite signs mixes to form sigma antibonding molecular orbitals. S-px overlap, addition overlap, one S atomic orbitals and one px atomic orbitals having the opposite sign mixed to form sigma antibonding molecular orbitals. Subtraction overlap, one S and one px atomic orbitals having the opposite sign mixes to form sigma antibonding molecular orbitals. Py overlap, addition overlap, two py atomic orbitals having the same sign. Subtraction overlap, two py atomic orbitals having the opposite sign to form pi antibonding molecular orbitals. Similarly, PZ overlap like PY overlap, and also it has pi bonding and pi antibonding molecular orbitals. Condition of linear combination atomic orbitals. In order to form molecular orbitals, the atomic orbitals should follow the following conditions. The atomic orbitals participating in the formation of atomic orbitals should have approximate same energy. The atomic orbitals should overlap each other as well as the possible is called maximum overlap of atomic orbitals. The atomic orbitals should have same symmetry among the molecular axes, and this is also called symmetric condition for LCAO. Relative energy of molecular orbitals up to 14 electrons. You have to consider, you have to remember here, this is the 1s bonding and anti-bonding. It is the simple sigma 1 is bonding, sigma 1 is anti-bonding, sigma 2 is bonding, sigma anti-bonding, and sigma anti-bonding 2 is. In case of P, you have to consider pi 2, pi 2p, pi 2p, y, pi 2pz bonding, sigma 2px bonding. Then after pi anti-bonding 2px, pi anti-bonding 2pz, pi sigma anti-bonding 2px for up to 14 electrons. But in case of more than 14 electrons, you all are the similar, but in case of 2p, you have to remember this sigma 2pz, sigma 2px, pi 2py, pi 2p, pi 2py, pi 2pz, pi 2p, pi 2px, pi 2py. But sigma is the first sigma 2pz and sigma 2p is the first and pi is the com. You have to remember more than 14 electrons. Up to 14 electrons, pi to p x and pi to py, pi to y, pi to z. And for more than 14 electrons, you have to remember these energy levels. In case of up to 14 electrons, you have to remember these energy levels. See, for example, hydrogen, 1, 2 electrons, sigma bonding, one is bond order, number of bonding electrons, number of anti-bonding divide 2. So 2, that is the single bond. Magnetic property, since the electrons are paired and it is diamagnetic. Helium molecule, 2 electrons after sigma bonding and sigma anti-bonding. So bond order 0. In case of lithium, sigma bonding, sigma 1 is bonding, sigma 2 is anti-bonding, sigma bond is bonding, sigma 2 is bonding. So bond order 1. In case of beryllium, in case of oxygen, see, remember this example, oxygen, sigma 2 is bonding. You can write also from sigma 1 is bonding, anti-bonding, sigma 2 is bonding, sigma 2 is anti-bonding, sigma 2p, pi 2p, pi 2p, and pi star 2p, sigma star 2p. In case of oxygen molecules, in case of O2 plus, in case of O2 minus, in case of fluorine, all are similar. In case of neon, but in case of nitrogen, remember this example, sigma 2 is bonding, sigma 2 is anti-bonding, pi 2p bonding, sigma 2p bonding, and pi 2p anti-bonding, sigma 2p anti-bonding. You have to remember example of nitrogen and oxygen for example. So you will understand all of the molecular orbital writing. In case of neon, in case of nitrogen oxide, difference between a valency bond theory and molecular orbital theory. According to valency bond theory, atomic orbitals do not lose their identity in the molecules. According to molecular orbital, atomic orbital loses identity to form new kinds of orbitals called molecular orbitals. Only valence shell atomic orbitals participate in bonding. All the atomic orbitals of the atoms participate in bonding. In atomic orbitals, the electrons are influenced by single nucleus, that is monocentric. In the molecular orbitals, the electrons are influenced by atom or molecule, that is polycentric. It cannot explain the paramagnetic property of the molecule oxygen. It can explain the paramagnetic properties of the all molecules. It does not explain the formation of molecular ions like helium. It can explain the formation of the molecules. It do not consider fractional bond order. It considers bond order. Resonancy play important role in PBT. Resonancy has no role in MOT. Polarization of covalent character. Structure of inorganic especially invalid delocalized pi bonding. Okay, it's all about molecular orbital theory. Thanks for watching. And I have already discussed about valence shell electron pair repulsion theory and valence bond theory, BBT. Thanks for watching and best of luck for your coming exam. That's now. Bye bye. See you again.